Hello, folks. Welcome back. Mr. Vance here with another award-winning video. This time we have a new subject. We are talking about statistics. So this is the first in my AP Statistics video series, and we are going to be working this year through the book, The Practice of Statistics, and this is the fifth edition of this book. So it's been around quite a while. It is considered one of the gold standards, if you will, for AP Statistics. So this book is going to get us. This book is going to get us where we need to go. I cannot explain why. There we go. Right off the bat, we have pandemonium in the Vass house. Hold on a sec. Okay, all is secure. We're safe here and ready to go. I can't explain why there are flamingos on the cover. In fact, I can't think of anything less exciting to put on a cover of a book, unless perhaps there were manatees on the cover. That would make it even worse. I mean, if I were writing a statistics book, I'd probably put Sasquatch on the cover. But anyway, the authors can choose to put whatever on the cover they want. Trust me, it's an outstanding book. And here we go. We're going to start chapter 1 here. The title of chapter 1 is Data Analysis, and there's a little introduction section in chapter 1 that is worth doing a few examples from. Vocabulary is huge in the study of statistics, so we're going to start most of our lessons with some new definitions and then be expected to use those throughout the rest of the course. And these are 5 of the most important definitions that we're going to work with all year. Individuals are the objects described by a set of data. Individuals could be people, animals, or things, and this part right here is important. Just because it's not necessarily a person doesn't mean it can't be an individual. When we talk about an individual being things, it could be like households. Households in the United States, each of those could be individuals. In fact, those are individuals in the U.S. Census. A variable is any characteristic of an individual. It can take different values for different individuals. And then we have 2 different types of variables. We have categorical and quantitative. Categorical puts an individual into one of several groups. Quantitative takes a numerical value for which it makes sense to find an average. So basically, if you can do arithmetic with the value of the variable, it's a quantitative variable. And then last but not least, you'll hear me use the word distribution about 5,000 times between now and the end of the year. Distribution of a variable tells us what values the variable takes and how often it takes these values. So again, these definitions must be, you must be able to use these definitions effective immediately. All right, so let's see what we got next. It's our first example. U.S. Census data. Here's information about 10 randomly selected U.S. residents from a recent census. So we've got state, family members, age, gender, marital status, total income, and travel time to work. And then we have some questions about this set of data. So what I'd like you to do is take a look at the table, take a look at the questions, think about it a little bit before we go through those answers. Okay, so here are the answers to these questions. We'll write them out and then take some time to discuss them. Okay, there's the answers to our first 3 questions. Let's talk about those quickly. Who are the individuals? It's the 10 randomly selected U.S. residents. What variables are measured? Well, the categorical variables are state, gender, marital status, and the quantitative variables are family members, age, total income, and travel time. Remember, a quantitative variable is a variable that can be averaged. So it would make sense to take an average of, find the average number of family members in this distribution, or the average age of the individuals in the distribution, or their average income, average travel time. It would not make sense to find an average state or an average gender. That for categorical variables, we can't find an average because we can't add those things up. What we could do is we could find out which gender is most frequent or which State is most frequent, and that's a different type of question, different type of math than taking an average. Okay, the individual in the first row, that's easy. She lives in Kentucky, has 2 family members, 61 years old, married, $21,000 total income, and then takes her 20 minutes to get to work. Now, let's talk about this last question. Part D, are there any individuals that stand out in the data? Well, this is a kind of a subjective question. And we might look at the data and say, well, the first row, that individual stands out because she is the oldest person in the distribution. But there, we might say that the person in California who's 30 years old stands out because they only have 1 family member. So again, this is a subjective question, but if I was picking the one that stands out the most to me, I would say it's this person right here. We have a 22-year-old male from Virginia that only earns $3,000 a year and has 0 travel time to work. So perhaps this person is a student. Again, subjective question, but are there any individuals that stand out in the data? To me, that's the one that stands out the most. Okay, let's move on and take a look at this next question. It says, drawing conclusions that go beyond the data. From the data in the previous example, 7 out of 10 individuals were married. Can we conclude that 70% of all U.S. residents are married based on this data? Well, the individuals are U.S. residents, and 70% of them in the table were married. But can we make this conclusion? Can we make that jump from the data to the population? And the answer is, well, not yet. And here's the reason why. Drawing conclusions that go beyond the data, that's called inference. So drawing conclusions that go beyond the data is called inference. And that's going to be a big part of our study of statistics because that's what statistics is all about. Can you take a look at a small set of data and then draw conclusions on the larger population? Fortunately, we don't have all the tools yet to make that connection, but it will be a big part of our study of statistics going forward. Okay, folks, that's it for the little intro here to Chapter 1. Stay tuned for the first section, Section 1.1.